Hi friends, welcome to the Unit 5 Day 3. This section is all about similar polygons. I'm in a different recording space. I'm at my house, so just kind of heads up if you hear any weird sounds. I think my neighbors just decided to learn how to work out upstairs, so I apologize for that. The big thing to note in this section is that we're going to be really focusing on getting everything correct in terms of order of not only letters, but symbols, numbers. So you're going to see me actually reference my notes in this section a little bit more than I would in previous ones. That's just because I want to make sure that I get everything written down correctly. For example, the idea of a similar polygon, for polygons to be similar, there has to be a lot of requirements for it to be met. Now, similar isn't the same as congruent. So if I said that two things are congruent, they're exactly the same. Similar means that they're close, and we have to talk about how they're close. So first we have to talk about two polygons are similar if their corresponding angles are congruent. So remember, that symbol is the congruent symbol, equal sign with the tilde above, and corresponding sides are proportional. So in this particular diagram, we've got these two polygons that look like they're similar. For them to be similar, we have to match up a few things. I'm going to do my best to use some different colors here. They may be close, it may appear close on the screen. I apologize, I'm doing the best I can. So first we're going to say angle E and angle A are congruent. So I used a congruency arc to show that. And then I'll do the same with angle B and angle F. So I used 2 for those. And then angle C and angle G. So I'm going to use, you guessed it, 3 congruency arcs for those. And then H and D, 3, 4. So this will be hard to squeeze in. Did it. There we go. All right. So you can kind of tell the difference. So I'm going to actually list them out. So angle A is congruent to angle E. Angle B is congruent to angle F. And angle C is congruent to angle G, and angle D is congruent to angle H. Okay, now that I have all those, I can start talking about the side lengths. So for the side lengths, for them to be proportional, essentially what we have to do is we have to make a kind of a consistent pattern. So if you think about it in terms of the length of A to B, so if we're talking about this first polygon being similar to the second, so A to B, whatever the ratio of this side length over this side length, so A to B, has to be that ratio. So however long this is over this amount. So say this amount is twice as big as this one, then that has to carry on through the rest of it, where this side length is also twice as long as this side length. And this side length is also twice as long as this side. Or, you know, I'm using that one as an example, but pretty much whatever it is. So that proportion has to be the same. Now, I'm not saying that the lengths have to be the same. I'm saying the proportion. So when we divide these two numbers, it has to be the same all the way through. So I'm checking. You'll see that when I do this, I go through, did A to B first, A to B here. So for the second proportion, it starts here, B to C over, and then the same here, F to G. And then C to D over G to H. So that proportion has to be similar to the last one, or sorry, equal to D to A. You see I'm just following around this polygon shape, H to E. So if all of that's true, then we can say that these two polygons are in fact similar. And remember, we list polygons that have more than 3 sides. We list them out all with a capital letter. So A, B, C, D. Order matters. So how I say this is very important. How I write this is very important. So polygon ABCD is similar to polygon EFGH. So that's just setting everything up. So this allows us to say that they're similar. So now with the examples, what we can do is we can actually jump into talking about listing the pairs of congruent angles, listing all the sides, seeing if they're equal, and then seeing if they are equal, then we can write a statement of proportionality. So here, I told you starting out that this triangle is similar. So because it's similar, then I know angle R is congruent to angle X. Angle R is congruent to angle X. And I can actually just read that from this diagram up here, up top. I can actually just read that. Let's see, angle S is congruent to angle Y. Angle S is congruent to angle Y. And then angle T is congruent to angle Z. Congruent to angle Z. So there's all of my pairs of congruent angles. It says check that the ratios of the corresponding sides are equal. So essentially what we want to do is we want to see, do these reduce to be the same thing? We're going from the first to the second. So when I write this out, I need to go from the first to the second. So we're going to do RS over XY starting out. RS is 20. The length of XY is 12. So 20 over 12. Let's see, 4 goes into both of those. 5/3. So that's me checking 1. I'm going to have to do this with 2 other sides. So just kind of prepare yourself mentally for that. So this one, ST over YZ. ST is length is 30, and that length is 18. 3 goes into both of these. So does 6. 6 goes into 30 5 times. 6 goes into 18 3 times. So we got that one as well. Then the last one, TR over ZX. TR is 25, ZX is 15. 5 goes into both of these. 5 goes into 25 5 times. 5 goes into 15 3 times. Now we need to write the ratios of the corresponding side lengths in a statement of proportionality. So I'm going to say, essentially it's all of what we had here, just dropping what all of these equal sides are, because it equals the same thing. Those proportions are the same, so these values are the same. So RS over XY is the same as ST over YZ, which is the same as TR over ZX. So that's a statement of proportionality. Here we have, given these triangles that are similar, so given these 2 triangles that are similar, list all pairs of congruent angles and then write the ratios in a statement of proportionality. So I know already that they're similar. So I know that angle J is going to be congruent to, remember angles are congruent in similar triangles, angle P. I know that angle K is going to be similar to angle Q. I know that angle L is going to be similar to angle R. Now I know that all of these side lengths also have to be proportional. So that means JK over PQ is going to be equivalent to KL over QR, which is going to be equivalent to LJ over RP. Order matters, and the order does matter that I'm going through and doing this. So here is here's the listing all the pairs of the angles, and then also listing the sides. If you look in the teacher notes, it actually has a diagram drawn here, and this is always my suggestion. If there's not one given, if you can draw a diagram, just draw it. It's helpful to be able to see what's going on if I was to make a rough sketch. Now, that's the other thing to note. These are rough sketches. They don't have to be perfect. So here's J, K, L, P, 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 Q, and R. And so then you can fill in, again, just like we did up above, to verify that these are in fact similar. Next video, we'll start with the scale factor. Have a good day.